It is a distinct privilege to be on the stage here again this year. And I'm very excited to be presenting to you the work of Intel Web Platform Engineering team, the team that has contributed over 15,000 patches to the Chromium project, the open source foundation of the Chrome and browser, as well as the Edge browser. I'm Moh Haghighat, Intel Fellow. I lead all Intel's work in the area of web technologies. At Intel, we have been proud of Moore's law that has been driving the computing industry. Essentially, it is about doubling the size of the number of transistors on a chip over like a year or 18 months. It seems Jason is establishing May's law, which is doubling the size of web AI audience every year, and I wish him best of luck. So last year, when I talked here, we had already released our flagship product, Lunar Lake AI PC, with 3 execution engines: CPU, GPU, and NPU. CPU for fast, quick, small AI inference, GPU for throughput, large model, and NPU for use cases that require sustained, power-efficient execution. Now, today, I will talk about the progress that we have, the advancement that we have on WebNN, on WebGPU, as well as in W3C Web Machine Learning Working Group. And I will give you a glimpse of our exciting next-generation product codenamed Panther Lake, which will be released in January. We announced it last week. Basically, 2 major progress we have had on WebNN. We have doubled the performance of WebNN on GPU, and we have majorly increased the coverage of WebNN on NPU. WebNN is an emerging standard web API being defined at W3C. My brilliant colleague Ninjin Hu and Dwayne Robinson from Microsoft are the co-editors, and we have been very closely working with Google browser team in having that in Chrome browser and in Edge browser. Double the performance of WebNN execution on GPU, the only API for general inference web API that can run on all these execution engines, CPU, GPU, and NPU. And this is thanks to the new architecture, Windows ML, by Microsoft that supports independent hardware vendor execution provider. For us, that EP is OpenVINO, which is highly optimized for CPU, GPU, and NPU. The implementation has been simplified. We used to go to XNNPack through TF-Lite for CPU and to DirectML for GPU and NPU. Now, we just go through WinML, OpenVINO execution provider, for all of these engines. And we get major improvement across the board. You see here major improvement, more than doubling the performance on GPU. Now I'm going to show you a number of demos side by side, where we were last year and where we are right now. On the left side is last year, and on the right side it is right now. And basically showing the progress in software, the same hardware. Segment anything. You see, we used to run that in like 30, 34, 38 milliseconds. Now we are doing it in 13 milliseconds, 12 milliseconds, more than double time faster. 12 milliseconds is amazing. Next, I will show a demo of whisper-based speech recognition. And last year, we had it 43 tokens per second. And now it is 100 tokens per second on GPU, and it is 98 tokens per second on NPU. Really, really fast, the same API. Next, I'm going to show you stable diffusion. It's like you ask the system to generate an image with certain characteristics. Last year, we were happy that we had just got below 1 second, 900 milliseconds, or so on. Now we are doing it in 400 milliseconds on GPU and like 600 milliseconds on NPU. I have a demo by the table. You just come there, the laptop is there, and you can experiment with that. It's pretty amazing. 400 milliseconds, less than half a second. Much, much faster than if you go to ChatGPT and ask for that to be generated. And everything local, everything private. Next, here I'm going to show you a number of demos that are possible on NPU because of the great contribution by Hugging Face and Joshua Luckner, who will be the speaker after me. He brought 20 top Whisper Transformer.js models to WebNN. And on the left side, you see basically the execution of depth anything, like depth estimation, the closer, the wider, on GPU, and on the right side, you see NPU. And at the bottom of the video, you can see Task Manager demonstrating that GPU is busy on the WebNN running on GPU, and on the right side, you see NPU is busy doing the work. Next, here I'm going to show you background removal, another demo of Transformer.js. I'm sitting in my home office, and I toggle to you see how quick it removes the background. And those are, by the way, real books. And you see on GPU and on NPU, really good performance and happening, again, same API, being able to run on all these engines. And next, here you see object detection. I'm showing an object, and the object is detected. Left side, again, on GPU, right side on NPU. Here I'm showing it a book, and I think I should charge Eric Schmidt for advertising the book, especially when this goes on YouTube, or a bottle. And again, you see this is happening with 30 frames per second on GPU and about 20 frames per second on NPU. The same API is capable to deliver such an astounding performance. We have also enabled GPU on Windows 10, which doesn't have Windows ML, as well as on Linux. Last year, we could only run WebNN on CPU through XNN Pack. Now, in addition to CPU, thanks to the highly optimized kernel of MLDrift, we can actually run that on a GPU on both older system, Windows 10, as well as on Linux. And one major optimization that is ongoing, it's in the works, it is optimizing the buffer reuse between CPU, GPU, and NPU. Already 18% performance improvement on the communication between CPU and GPU, and 50% performance improvement on the KV cache. This is going to facilitate WebNN and WebGPU interoperability so that application can use these two APIs simultaneously with communication between them minimized. Like, for example, Google Meet might use certain things with WebNN, certain things with WebGPU, and again, communication highly optimized. Now, WebGPU, 3 major progress: enhanced memory bandwidth utilization, improved thread occupancy with SIMD, as well as enabling Intel matrix extension, XMX. Basically, here we are selecting the tiles based on the register file size and also subgroup matrix with the right width of the SIMD operation. These we are all doing it under the system. As developers, you don't have to worry about that. As a result of that, matrix multiply, which is the primitive for AI, is improved in performance by a factor of almost 2x. And another area, here is a demo of WebGPU running basically with this optimization that I mentioned, and without it. And you basically see significant improvement from like 15 tokens per second to 20 tokens per second because of this optimization. Now we have XMX enabling in the work. We have already enabled that on the Vulkan path, and there basically WebGPU gets advantage of these matrix extension capabilities, engines that are in Intel platform. And we are also and this can already be used. The built-in AI that Parisa mentioned already can enjoy this major improvement. And we are working also with Microsoft on enabling XMX through D3, D12. That is work in progress. Hopefully we'll get there, and you will have it on Chrome browser, on Windows as well. And here is this speed up that we are already seeing it on the Vulkan path, like 1.8 X speed up. This is like amazing speed up on WebGPU through these lower level optimizations. Now, it is a privilege to be giving you a glimpse of our major next client platform, codenamed Panther Lake. It is the first client platform on Intel 18A technology. It offers a 50% faster CPU, a 50% faster GPU, and an enhanced power-efficient NPU. It delivers 180 tera operation per second. And if you recall, Lunar Lake, it had up to 120 tera operation per second. It's major improvement across CPU, GPU, major efficiency improvement on NPU. Panther Lake introduces XE3 GPU for scaled performance without compromising power efficiency. Scalability is the name of the game here. You can, XE3 supports up to 12 XE cores. Different configuration can have different number of XE cores. Each XE core has 8 XMX engines. XE3 XMX engine is the primary AI acceleration, integrated AI acceleration engine. It supports up to like 1024 32-bit operation, or 2048 16-bit operation, or 4096 8-bit operation. Per clock cycle, it is mind-boggling. In integrated GPU, each core running basically 4096 8-bit operation. This is like supercomputer on an integrated GPU. Panther Lake also enhances its AI capabilities by a newly designed NPU 5, delivering high performance and small footprint, optimized for both area and power efficiency. Compared to Lunar Lake, it has about 40% better performance per area, means 40% more power efficient. It is expected to be released in January. Web AI is going to shine on Panther Lake. We also have had major progress at W3C Web ML working group that is chaired by my colleague, Anssi Kastainen. We have had 30% growth in companies and organizations participating in WebML and WebNN working group, and new community groups have been developed for agentic experiences, WebMCP there, and built-in AI, like about 200 participants we have there. Newcomers to the working group, official working group, are like Hugging Face, Joshua Lochner, the next speaker. Personally, he represents Hugging Face, and I especially thank him for his major contribution to WebNN, as well as Qualcomm, as well as ARM. Will Lord will talk before noon today, and NVIDIA and others. So major progress in coalition in defining these ubiquitous APIs that will run on all browsers, on all hardware platforms. Very, very pleased with that. WebNN is available on Windows ML general availability right now. You can download and enjoy all these experiences. Join us in shaping the future of WebNN. Very excited about that. And here I have additional link. And now I would be very I'm pleased that Joshua comes and speaks. And I thank Jason for scheduling him after me. Otherwise, nobody would have listened to me. Thank you so much.